Yes, we have to find the Fourier series for the function f of x is equal to x cube in the interval minus pi less than x less than pi, and f of x plus 2 pi is given as f of x. F of x plus 2 pi is equal to f of x means the function is periodic function with period 2 pi. What is important for us is the interval. Here it is given that f of x is x cube in the interval minus pi to plus pi. See, the question is find Fourier series. It is asked to find the Fourier series or Fourier expansion for the function f of x is x cube in the interval minus pi to pi. So whenever it is asked to find Fourier series for any function in the interval minus pi to pi, first we must check whether the function is even or odd. Now here f of x is given as x cube in the interval minus pi to plus pi. To check whether the function is even or odd, we replace x by minus x. X की जगह minus x put करो. We get it as cube of minus x, which is minus x cube. Now see, f of x is x cube. F of minus x is minus x cube. Minus into f of x, if you multiply this f of x by minus 1, you will find it is minus x cube. You can see that f of minus x is equal to minus into f of x. F of x is x cube. F of minus x is minus into x cube, and if I multiply f of x by minus 1, we get minus f of x is also minus x cube. So we can see that f of minus x is minus x cube, and minus into f of x is also minus x cube. So f of minus x is equal to minus f of x. So therefore f of x is an odd function. F of x is an odd function. So we know that if we replace x by minus x and if it becomes negative, it is an odd function. Given function is an odd function. Odd function in this interval minus pi to pi. And if f of x is odd function, we know that a0 is 0 and an is also 0. And the Fourier series is given by the formula f of x is equal to summation n is equal to 1 to infinity Pn into sine of nx, where we know Bn can be found using the formula 2 upon pi integration 0 to pi f of x into sine of nx dx. This is the formula to find Bn. Now in our case f of x is x cube. We'll substitute f of x as x cube, and so then it will become 2 upon pi integration 0 to pi x cube sine nx dx. So for that integration x cube into sine nx dx, we'll have to apply the formula of integration by parts, integration uv dx. So Bn, we are going to get it as 2 upon pi integration with limit 0 to pi f of x will substitute as x cube into the sine nx dx as it is, into sine of nx dx as it is. So remember, here x cube is an algebraic function, sine nx is a trigonometric function. So according to the order of Eilert or Light, we know algebraic function comes first and then we get trigonometric function. So we must check according to the order of Eilert or Light. Algebraic function x cube comes before the trigonometric function sine nx. We are going to use the formula of integration by parts. The shortcut formula of integration by parts, integration uv dx, is u into v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus the fourth order derivative of u into v5 minus dot dot dot. We know in this formula we get alternate plus minus sign. We get alternate plus minus plus minus. We know dash represents derivative. U dash is the derivative of u. U double dash is the derivative of u dash, and so on. Suffix represents integration. V1 is the integration of v. V2 is the integration of v1, and so on. Now, you see here in our case, u is equal to x cube. So therefore, u dash derivative of x cube we know is 3x square. U double dash, derivative of 3x square. So 3 is a constant, derivative of x square is 2x, so it becomes 6x. 3 into 2x becomes 6x. U triple dash, derivative of 6x will become 6, and whereas the fourth order derivative of u will become 0. So when highest power of x is 3, we'll get term still u triple dash. So we need to find term still v4. v5 we don't need to find because the fourth order derivative of u is 0. Now remember, we can apply this shortcut formula only when u is algebraic, some term like x, x square, x cube, etc. Because if you go on differentiating algebraic term, it becomes 0 afterwards. Now here v is sine of nx. V is sine of nx. V1, remember, represents the integration of v. V1 is the integration of v. It is integration of sine nx. Integration of sine nx, remember, is minus cos nx upon n. That is V1. V2 is the integration of V1. So it is minus 1 upon n into integration of cos nx dx. So it comes out to be this minus 1 upon n, as it is integration of cos nx is sine nx upon n. So therefore we get V2 is minus sine nx upon n square. In the exam we can skip these steps, we can directly substitute the values in the formula, but I am writing this in details just for our understanding. So we have got V1, V2, then V3. V3 is the integration of V2. So it is integration of minus sine nx upon n square. Say I'll take that minus 1 upon n square outside. It will be integration of sine of nx dx. Integration of sine nx dx. And again we know integration of sine nx dx is minus cos nx upon n. So this minus 1 upon n square as it is into integration of sine nx is minus cos nx upon n. So it comes out to be minus into minus will be plus, is cos nx upon n cube as our V3, and we have term still u triple dash, so we'll need V4 also. V4 is the integration of V3. So V4 is integration of this term, integration of cos nx upon n cube. Again we can take 1 upon n cube outside, integration of cos of nx dx is sine nx upon n. So it becomes sine of nx upon n raised to 4. So see, V was sine nx, V1 is the integration of sine nx, which is minus cos nx upon n. V2 is the integration of V1, which comes out as minus sine nx upon n square. V3 is the integration of V2, so which comes out as cos nx upon n cube, and V4 is the integration of V3, which is sine nx upon n raised to 4. So we saw that in this question we have to integrate this term x cube into sine nx. To integrate that, we are going to apply the formula of integration by parts, integration uv dx, and we are applying this shortcut formula of integration by parts for this. So now if you apply the formula, you see bn will be 2 upon pi. We'll write this 2 upon pi as it is outside the integration. Now if you substitute the respective values, remember it is u into v1, u is x cube, u is x cube, our v was sine nx, so v1 is minus cos nx upon n. Remember it is u into v1 minus u dash, derivative of x cube is 3x square, it is u into v1 minus u dash into v2. V2 is the integration of v1, integration of minus cos nx upon n is minus sine of nx upon n square. So u into v1 minus u dash into v2 plus u double dash, derivative of 3x square will be 6x, and integration of this term will be cos of nx upon n cube. So see, it is u into v1 minus u dash into v2 plus u double dash into v3 minus u triple dash, derivative of 6x is 6, integration of cos nx upon n cube is sine of nx upon n raised to 4. So see, we apply the formula by parts, u into v1 minus u dash into v2 plus u double dash into V3 minus U triple dash into V4. Next term, the fourth order derivative of U is 0. Derivative of 6 is 0. So we won't get the next term, and this is within the limit 0 to pi. We have applied the formula of integration by parts, U into V, and now we'll substitute the limits wherever there is x. Before we substitute the limits, let us simplify. So this we can write it as, see, this 2 upon pi as it is outside the bracket. This minus into plus will be minus x cube cos of nx upon n, minus into minus will be plus 3x square sine of nx upon n square plus 6x cos of nx upon n cube and minus 6 sine nx upon n raised to 4. Now we'll put the limits in place of x. We'll substitute the upper limit pi in place of x. Wherever there is x, we'll put the upper limit pi first. Remember, sin n pi terms are going to become 0. Sin n pi terms will become 0. Cos n pi we know is minus 1 raised to n. So cos n pi terms will exist, but sin n pi terms will become 0 when you put the upper limit. Similarly, when we put the lower limit 0, sin 0 becomes 0. So suppose we put the upper limit first pi, it is going to be pi cube into cos n pi upon n plus 3 pi square sin n pi upon n square plus 6 pi cos n pi upon n cube minus 6 sin n pi upon n raised to 4. See, the terms of sin n pi, they are directly going to become 0. This term of sin n pi will become 0. So in exam, like, you may skip some steps, directly you may write 0 here, minus the lower limit. So see, this first bracket we have got by substituting the upper limit pi in place of x. So here the upper limit is pi. So the lower limit is 0. We'll put the lower limit 0 in place of x. See, 0 into cos 0 will be 0. 0 into anything is 0. And 0 into sin 0 will be again 0. 0 into cos 0 will be 0. The third term also becomes 0. In place of x, we are writing 0 now. 0 into cos 0 will become 0. Last term is of sin 0. That also again becomes 0 because sin 0 we know is 0. So when we put x is 0, this complete bracket is going to become 0. First three terms become 0 because it is x into something, like 0 into cos 0 will become 0. Here also 0 into sin 0 will be 0. 0 into cos 0 will be 0. Last term becomes 0 because here it is sin 0. We know sin of 0 is 0. That's why that term becomes 0. Cos 0 is 1. We know sin n pi is 0, remember. So sin n pi term becomes 0. Cos n pi becomes minus 1 raised to n. Cos n pi is minus 1 raised to n. So see, substituting these values, we'll get Bn is 2 upon pi cube into cos n pi is minus 1 raised to n upon n. Sin n pi term is 0. This next term is 6 pi into minus 1 raised to n upon n cube. Remaining terms are going to be 0. Now, yes, we may take pi common, or we can multiply this 2 upon pi inside the bracket. After substituting the upper and lower limit and substituting the value of cos n pi as minus 1 raised to n, we get this term. We can open the bracket, we can multiply 2 upon pi inside the bracket, so that this becomes, multiply 2 upon pi inside the bracket to this first term, this becomes 2 pi square into minus 1 raised to n upon n. If you multiply it to the second term, pi gets cancelled, 2 into 6 will become 12 into minus 1 raised to n upon n cube. So that is our Bn. Once we have got Bn, we'll substitute that. in the formula of Fourier series. We have got Bn as 2 pi square minus 1 raised to n upon n plus 12 minus 1 raised to n upon n cube. So we know Fourier series for a odd function, Fourier series for odd function f of x in the interval minus pi to plus pi is given by f of x is equal to summation n is 1 to infinity Bn sine of nx. If you substitute the respective values, f of x is x cube. You substitute the value of Bn. See, it is 2 pi square minus 1 raised to n upon n. It is 2 pi square minus 1 raised to n upon n plus 12 into minus 1 raised to n upon n cube. As the value of Bn, we just substitute the value of Bn into this sine of nx as it is. This is the required Fourier series. The required Fourier series as our answer. You see, whenever it is asked to find Fourier series of a function in the interval minus pi to plus pi, first we should check whether it is even or odd. Now, in this case, it was an odd function. So, a0, n is directly 0. We just found out Bn using the respective formula and substitute in this series, this formula of Fourier series. We get our answer.